Here we have a question about a spring. Spring is attached to the ceiling and pulled 18 centimeters down from equilibrium and released. The amplitude decreases by 8% each second. The spring oscillates 12 times each second. Find an equation for the distance t. The end of the spring is below equilibrium in terms of t seconds. First, let's notice that the spring is pulled down 18 centimeters, so that tells us that we're looking for when the amplitude is 18, because that would be the maximum amplitude as we begin, because afterwards the amplitude decreases by 8% each second. So how we interpret that piece of information is amplitude initial value is 18, but we're decreasing by 8% each second. So that means that a of t, or amplitude function, is going to be 18 times 0.92 to the t. Okay. Now we know it's going to oscillate 12 times each second. So there they give us the frequency. So usually the frequency is written f. F is 12. Period is usually 1 over the frequency. So the period is 1 over 12. And we're going to use all this information here to write the equation d of t. So d of t is equal to, we'll start to write the equation. Now we'll just go bit by bit. First we'll write the amplitude function. And because we're starting at 18 centimeters, we know that we're going to be using a cosine function, because cosine starts either at a minimum or a maximum. So we're going to use a cosine function, so cos. Now we need to find the coefficient b, t. So the b coefficient is given by solving this equation. 1 over 12 is equal to 2 pi over b. So that implies that 24 pi is b. So cos 24 pi t. And we're not shifting, so the phase shift is 0. And we're not starting at another value. We're not shifting this up or down, so there's no transformation up or down. So this would be the equation that we're looking for this spring problem. Up next will be another spring problem.